So hi everybody, my name is Nancy Diaz El Sayed. I am the Sustainable Manufacturing Specialist on the Sustainability Solutions team at Autodesk. And I am accompanied today by my co-presenter, Ani Diodar, who's the Senior Product Manager on our team as well. And today we're going to be talking about managing factory operations with the Internet of Things. Very popular topic today, it seems, with the keynote presentation. And so what are some of the key learning objectives? We'll be introducing 4 primary workflows that look at managing energy consumption, improving thermal comfort of occupants, looking at asset utilization so you have a better sense of what performance is of the equipment on your production floor, as well as looking at asset management. So how can you better maintain the assets within your facility? And the standard safe harbor statement. So most of the features that we'll be presenting today are readily available through our technology preview, our Autodesk Lab site, so you can try it out for free. But in case we start talking about our roadmap, this is not something that should be used to make future purchasing decisions. So let's talk about IoT. There's been a tremendous growth, an exponential growth that we've probably all been very well aware of over the past few decades. And Cisco estimates that by 2020 there will be something like 50 billion devices that are connected to the internet. And they range dramatically in terms of the functionality. So wearables is a very popular emerging trend. Looks like I stopped working. Okay. We see the prevalence of the Fitbit that helps you track your activity and monitor your health. I'm wearing one myself. You can track the number of steps, and it's making it very accessible to consumers. I'm able to compare, San Francisco very easily reached 10,000 steps versus I'm now living in Tampa, Florida, where it takes, a significant amount of effort to attain that, but that's a discussion for another time. And we also see something like what Layer has produced, their bracelet that can monitor the carbon emissions for a person. This is something that came out this year in 2015. It's also something that, the IoT is also something that's coming into our vehicles. So we see that there are some vehicles that have embedded some applications. So they offer the 4G LTE network so that you can, stream music, access weather data, and so on, right there on your dashboard. But what about in the factory space? There's been a significant trend over time. Right now we're experiencing what's been termed the 4th Industrial Revolution. In Germany, we know it as Industry 4.0. Here in the US, we talk about smart manufacturing. But essentially, we're moving from, the use of electronics in order to increase the automation within our manufacturing facilities to connected devices within our plants to help improve the operation of our facilities and have smarter factories. And there's just so much data that you can obtain from your production equipment and from the assets within your facility. If we take the example of a CNC machining center, you could start tracking the electricity consumption, the machining temperature, the vibration of your spindles. Perhaps it'll tell you information like, is my tool wearing, oil consumption, spindle speed, and feed rates. And when we start thinking about all of the data that you could obtain, we get into the problem of working with big data. So you don't want to end up in a situation where you just have loads and loads of data that's streaming, but you want to be able to obtain some actionable insights, some information that you can use to improve the operations of your facility. And if we look at different scales, a small shop could be producing 2 to 10 terabytes per year. But what does that mean at the enterprise scale? You're moving up to 80 to 5,000 terabytes of data in a year, which is significant. So we want to be able to dwindle this down to information that's useful to our factory owners, our plant managers, manufacturing engineers, and so on, so that they could take action within their facility. And so, this lends itself to some of the top manufacturing challenges that we're currently experiencing with our production facilities. There's a lack of collaboration across different departments, disparate systems and data sources. So you may have sensors from a vast variety of different manufacturers. How can you make sure that they're able to communicate with one another, perhaps on a common platform? Justifying the expenditures of making improvements, as well as a host of other things related to the supply and demand chains. There's a need, of course, for executive support, and as Carl mentioned earlier today, the availability of the appropriate talent for operating effectively. And now I'll switch it over to my colleague Ani, who will talk about a new cloud-based application that we've been working on that brings connected devices to our production facilities and commercial facilities alike.
Project Aquila is the name, and I know it rhymes with tequila, but that's not on purpose. And tequila actually reminds me, I know that the competition for this session is free booze and snacks on 5th level. I really appreciate all of you coming over and despite all of that and listening. And if you didn't know about that, ignore what I said. So Project Aquila, so we have seen this trend coming in. All of our customers are telling us about products as a services and instrumented buildings, instrumented connected products. And so we have seen this trend coming up over the last couple of years, and Autodesk tried to start that process very nascently by partnering with a few companies. We had a project going on with Johnson Controls. Now we have partnership with Schneider. We invested in this company called Lucid Design. We recently invested in Panoramic Power Sensors, which are really the heart of this product. And only now, over the last couple of months, have we really gone knee-deep into Internet of Things. We recently acquired a company called C Control. That's going to be our platform for all things Internet of Things. And Project Aquila is our first foray into what we call building Internet of Things, where all these connected sensors and products and equipments and BMS systems can come together, and we as a software provider can apply a very visually rich analytical layer on top of it that can allow you to easily see and foresee rather what equipments are working how and where the problem areas are. So that's the genesis of Project Aquila, and I'll pass the sensor along. This is really the heartbeat of Project Aquila. It's a wireless, batteryless, self-powered sensor that can be installed in minutes. It's non-invasive and starts beaming data in 3 seconds. So that's the kind of power we want to harness through our Internet of Things platform. Nancy mentioned that the LNS research has found out that the top challenge in manufacturing facilities is the lack of collaboration, because we all know how things get siloed very quickly. And Project Aquila is meant to bridge some of that, because not only does it allow sustainability managers think about their KPIs and goals, it also allows facility managers to operate their buildings more efficiently. Manufacturing engineers and building engineers understand equipment performance and degradation. And plant managers think about projects and ROI and financial benefits. So all of this have been packaged very uniquely inside Project Aquila, as you will just see, as you'll see soon. Oh, sorry. So how will you benefit? A few things. One is energy. So we start with energy. These sensors that I'm passing around measure amperes flowing through the wire. So that's the first step. Once you do that, we know how the building is performing, not only at an aggregate level, but down to the device level. And you can now track the energy goals, energy consumption against goals. You can track device level performance drifts. You can compare your performance with last year's performance. So that's one thing. Secondly, because electricity often becomes a proxy for maintenance, we can monitor the performance drifts and start thinking about maintenance issues. And when we connect this with our other product, building ops, it becomes even, the whole value proposition becomes even richer, because now you can do asset tracking and ticketing and service management through these products. Where Autodesk really brings its strengths is in BIM and 2D and 3D mapping. So not only can you see this data in a nice tabular way, in a real-time fashion, you can see this data being contextualized in 2D and 3D. So that now if you have a BIM, if you have a 2D floor plan, if you have a photograph, You can quickly upload those assets, link those assets to the sensors, and start seeing those data and start seeing this kind of traffic light kind of paradigm on which parts of the buildings are performing in which manner. And finally, financial analysis. So we also have a financial tool there which does life cycle cost analysis, so that if you are thinking of a project, you can start thinking about net present value and discounted paybacks. Even if you are not thinking of a project, you can start monitoring different scenarios and see what thresholds will help that project get executive approval. So the sensors, you are seeing that I'm passing them around, as I said, wireless, self-powered. They have semiconductors in them, so virtually maintenance-free. Very quick process of snapping them onto a circuit. In 3 seconds, they start beaming data. You can see how the kludgy old way of doing things are. If you have used to submeters and wired sensors and watt stoppers, you know how time consuming and costly it is, and also it takes up a lot of space. If you look at a watt stopper, it takes up half the electrical closet. Whereas here, you can just install these thumb-shaped devices in a couple of hours. And once you snap them on, you bring a router, you start beaming data wirelessly or through Ethernet or cellular, and you're ready to go. So the first workflow that we would like to talk about is just managing an energy and reducing energy footprint. And as I said, at least 3 personas, if not more, the facility manager, the sustainability manager, and the engineer can benefit from this workflow. Right at the outset, when you launch Project Aquila, you'll be presented with a rich dashboard full of KPIs and analytics. It tells you how your building is performing at an aggregate level, but also down to the device level. You can monitor which are the energy hogging equipments and what to do about them. It will present a heat map that shows you what the operating schedules are, so that you can spot some seasonal inaccuracies or just just equipment failures right away. And start answering questions like, are the KPIs meeting your goals or not? Which of those loads are energy hogs, and are you seeing some bad operating schedules? Next, we show real-time alerts. So right on the same page, very conveniently, you can see alerts that are related to power, of course. Is the equipment idling for too long, or are the equipments on during off hours? Are they cycling too frequently, which could actually indicate a maintenance problem? We have now also partnered with a temperature sensor company. So we actually, one of the reasons why we have put this on labs is to collect feedback from you to understand what other kind of sensors can we bring on this platform. So you can, with the temperature sensors, now you can start looking at too hot, too cold kind of issues. And then you can drill down into the actual device and see what's happening down to a 5-minute interval. So you can now see if it's flagged as a off hours consumption, you can go in and see why that device was on during off hours, what's going on, and have there been other issues that have been flagged over the course of time before that event happened? Meaning, has that equipment, like here, been consuming power that is more than the normal power rated for the equipment? And we statistically infer from the data what the normal operating condition of the equipment is and what the abnormal ranges are. And you can go and change them. So if you have an equipment that sort of is meant to work in off-hour or during off hours, or if it's meant to have those peaks, then you can go and change those thresholds. But we will look at the schedule and we'll look at the data and automatically tell you this is the normal operating range, and we are already seeing abnormal conditions. When we see that, we map that with your utility rate and tell you what your potential annual savings would be if you were to fix that problem. Not only that, we look back and say, if you had listened to us 3 months ago, you would have already saved so much money. And that we do by tracking all those events back in history and telling you how that mapped with your utility rates and what kind of savings would that have resulted in. The next is occupant comfort. So we now have also temperature sensors onboarded, so you can easily upload a floor plan, or in this case, a photograph, and link different parts of the photograph to temperature sensors, and now start monitoring ambient temperature. That way, an occupant can issue tickets if it's too hot or too cold. That will go into our product called Building Ops, which you may have seen in the morning session. It's a commercially available product now, and you can start tracking the service request. And in the manufacturing realm, you can also see if you attach these sensors to the equipment, you can start understanding the ambient temperature around equipment, because some of the equipment are sensitive to these ambient thresholds. And this workflow is around financial analysis. So we had started a financial analysis project last year, met with a lot of good feedback, and we have started rolling them into our other products. Now this tool, it looks at the energy consumption of your building. So it knows your OPEX, it knows the kind of events you're seeing, it knows the potential savings you can get. This tool allows you to now start recommending your executives, or if you're a consultant, recommending your clients on the kind of projects they can undertake and what kind of payback and ROI they can get right away within the tool. It'll take the right data from the sensors, get that plugged in. You can enter information around capital cost and how much energy savings you desire, and immediately you'll get the results around payback and net present value and IRR and so on, and see the impact on cash flow. And Nancy has a few more workflows, and I'll leave it to her.
Thank you, Ani. So when it comes to managing your assets, you're probably talking about your facilities team consisting of the facilities manager, engineer, or maintenance engineer as well. And so what Panoramic Power allows us to do is, just by looking at the power demand over time, we could see whether or not a device is operating appropriately. So here we can see an example where you have a pump that's working at, that's consuming the same amount of energy and is essentially running at the same state, regardless of what the chiller is doing. So you'd want it to sort of replicate what the chiller is doing and turn off when it's appropriate. In another instance, we have a chiller that stopped working. So you can set within the Panoramic Power Systems and also some of our own Project Aquila alerts, devices that should be running all the time. So if a device is consuming too little of power demand, we can alert the facilities team of that scenario so that it could be remediated. And so this just highlights some of the rules that you're able to configure on the Panoramic Power dashboard, so you can tell whether or not you're consuming high daily energy consumption, high power demand, too little power, if you're consuming, if your device is working when your facility is supposed to be off. Also, if it's idling, if it's short cycling, not cycling at all. And essentially all of these alerts allow the facilities teams to be notified via email, text message. They get streamed over to Project Aquila. And you are also able to set these alerts to create tickets within Building Ops automatically as well. And so we provide the contextualization of these alerts. So now you're not getting this big tabulated view of all of your alerts, of all of your energy consumption. But here you can see, okay, I have on my workshop, I have a number of different 3D printers. This is the example that we're presenting here. But we can see that there are two problem areas, one of which you have a device that's idling. So any of the alerts that we're picking up from Panoramic Power can be mapped onto the 2D floor plan, an image of your facility, in order to help better manage your assets. So this is a dashboard that a facilities manager can use at the beginning of their day to see where some problem areas are and dive into the details of what's going on within that asset. And this is another example where you can see it mapped onto a photograph. So as was shown previously with temperature sensors, you can do the same thing with alerts here.
That's something that has resonated with our customers. Sometimes customers come back and say, we don't have a bill right now, we have to go plan for somewhere else. Nothing's stopping you from just taking quick pictures of your then annotating them with sensors, and right away you can start getting that data and sending it to your executives and other stakeholders.
That's right. We found that 2D plans is something that's much more accessible to manufacturers than the 3D models. So we've incorporated both of those options so that customers can use them appropriately. And like I mentioned, if something does go wrong with your particular asset, you could dive into the details, see, okay, well, what was my power over the past week? Is this something that I could detect in future scenarios to help prevent failure in the future? So the last workflow that we like to present today is with respect to asset utilization. So how can you try to improve your production efficiency? And that's really one of the nice things about tracking energy consumption. So not only are we looking at, the sustainability side of things, trying to lower energy costs, reduce the consumption of resources, but you can also use the power demand to identify what's going on within the asset. So some factories will model the operations within the facility using something like discrete event simulation software. This is an example of what Autodesk offers, Process Analysis 360. So you can draw up your facility, put in all of your buffers, production equipment, and the relevant assumptions like mean time between failure, size of the buffers, and so on, and then output a report that tells you, this is what we should expect out of your facility. And so here I've taken an excerpt of the report that looks at utilization. So when do I expect to be producing versus idling, and so on. Looking a little bit closer at how we're using the data from Panoramic Power, this is an example of, how a machining center consumes power over time as we're cutting regular steel here. But on the Morisaki NVD 1500, these were just some experiments that I ran during my graduate studies. But one of the key takeaways is that, once you turn on your machining center, it's going to consume pretty much the vast majority of the power demand that it's going to consume when you're actually cutting material. It's surprising that, standby can make up about 75% of the energy consumption. So that's how we're able to tell what the state is of the device. And so here we can see how the profile changes over time once you start the cut, when you turn on the spindle, as you're moving the tables, which makes up a very small percentage. But as Ani mentioned, the power is essentially the heartbeat of Project Aquila, because it's able to tell you so much about what's going on within the devices. And so we use that power information to identify the states of the devices, so we can tell you, what percentage of the time is my machine off, is it operating, is it in standby mode. So here it's mapped onto the large model viewer, and you could drill down into other KPIs for that particular asset. So if you wanted to do a virtual walkthrough and see how your assets were doing. Here we drill down more specifically into the states of the devices at 5-minute interval data sets. And you can see, if you would like to operate at, say, 90% of the time I want to be operating and producing products within my facility, you could set that threshold so that you can see whether or not you're meeting your expectations. And so that's essentially it for all of the workflows that we wanted to discuss today. We talked about energy consumption, how to manage your energy, the occupant comfort, or just looking at temperature within your production facility, asset management, and then finally asset utilization. So we're trying to bring the value of information in real time to a number of different players within your production facility, from the business planning side of things, like your plant managers, sustainability managers, and those people that are trying to optimize the system, like your industrial engineer, the operations team, as well as those on the ground floor that are fixing the assets themselves. And so just to summarize, the current capabilities that are available So as we mentioned, this is something that you can try for free on Autodesk Labs, and we'll provide you with some sample data streams if you're not connected with Panoramic Power Sensors already. We're using some data sets from our own facilities in order to give you the experience of Project Aquila, but you land on your main dashboard page where you can see KPIs and power demand, electricity consumption over different time horizons. You can break down your facility. So let's say you have different shops, like an assembly area, paint shop, and so on. You can choose how you set up the dashboard and the categories themselves during the installation process. We provide quick and easy access to all of the alerts within the facility. So you can see, which devices are consuming energy or are turned on during my off hours, and what are the potential savings that are related to those particular devices. And you can export these results and share them with some of the key stakeholders within your facility. And once you have some energy conservation projects in mind, you can use our financial analysis tool to do different scenario analyses and see what the net present value would be, the payback period, the internal rate of return for these projects. And we have the 2D plan component where you can integrate or upload a PDF file. It could be an image, a floor plan, and associate it with the data streams, be it either the power data streams or the temperature sensors, and the 3D model component, so that you can see, over the last hour, what was the state of my devices, and it provides our users with a high-level overview of those devices, and you can drill down into the cost of electricity and the electricity consumption there immediately from the dashboard. And that's just about it. We're currently in the process of identifying some pilot projects. So we have some projects underway, and we're looking for about 3 more projects to do within the next few months, or to kick off within the next few months. This is an example. The next 2 months. And this is an example of what a pilot project could look like. So it varies tremendously. If you want to do a small project, let's say you only have 100 devices that you would like to track. It doesn't just have to be production equipment. Since it's at the device level, you can look at, the HVAC system components, your chillers, your boilers. Essentially, when you're setting up the pilot project, you'd want to identify, what are the devices that I like to track? What are the most important assets for the operation of my facilities? And so we can work with you and speak with our partner, Panoramic Power, to identify a pilot that could work for your facility. And that's about it. We'd welcome your feedback after the talk and the recording. I'll be uploading the latest slides from the presentation. Handouts are already on the Autodesk University site for you to access after the talk. But thank you very much for your time, and we'll open up the floor for any questions you may have. It looks like we finished pretty early, so you guys may be able to catch the booze and hors d'oeuvres. We can start over here.
So y'all are going to be installing all your own sensors. You won't be pulling in data from legacy existing systems like JCI or Schneider. Is that right?
There's separate sensors. Do you mean pulling information off of? So we'd be pulling the energy data sets and temperature sensors for ambient temperature within the facility. So we wouldn't be pulling information that's coming from another piece of equipment like a BMS system or anything like that. We're not tapping into that information.
We are going to feature for the CSV board. So that's where we learn to work with you. So we have a schema in mind, and we
It could be somebody on your premises, or they can hire somebody to assist with installation.
It seems like normally the manager that would be in this area, the manufacturing or sustainability manager, they're not used to looking at this type of data. So do you have like a training process? Because now you're giving them a whole lot of weird, heretofore unseen data that they have to start to pick apart and identify, ooh, this is good, ooh, this is not good, and understand that. Do you have a training process where these people learn what's good and what's not good in terms of the data?
No, now is the time because it's from labs. You have access to user forums, you have access to us. I mean, not that you don't have access to us, as a part of the commercial, but before it's gone through our test machinery, now is the time to really test it out, influence the product roadmap, make use of us and our developers, and have your folks trained up because we can support it much more closely as a team as opposed to just going through our marketing and sales channels.
I'm sorry, one more follow-up. Is there a manner to get machine level interrupts so you can just bypass the, weekly A4 sheet and, if you're watching a machine tool and the power goes way up, that you can have it programmed to
Control.
stop the machine or to change the feeds to speeds or things like that, or is it not at that level?
No, that feedback loop is not currently in place in Aquila. Yeah, so no control is implemented right now.
We will be learning that is something we would like to have because we have noticed people do not want software to control the building, yet they have given that kind of control to the BMS provider. I know a couple of companies have started claiming that they can now have high professionals, they can get data and control the system. And if that is important, then you can start working on that. Again, that's one of the benefits of helping implement this product and this approach right now, because that is a data that's
My question was your target audience. Is it something you see that you put those sensors on at the commissioning of a building and you just have them on there forever? Or they come in after a year to do enhanced commissioning analysis? Or they just come in once in a while? Or what do you?
They could come in after the fact. So that's the nice thing about it being non-invasive and pretty easy to install. Depending on where your facility is with respect to the accuracy of the electrical diagrams, that may be the most time-intensive portion of it, which would make things much easier if you were starting from the construction side of things. But yeah, Panoramic Power will work with you on sorting that out, and that just may be the longest portion of the process, but it could come either before or after the commissioning of the building.
What's not a good case is the MIB case where you do a retrofit and install the sensors there, and now you take the sensors off and move them somewhere else, and then you move them somewhere else for 3 months. It's not as if it cannot be done, but you won't get that kind of ROI because now you keep disrupting the workflow, do not get all the benefits that you get from dashboarding and KPIs. You just are doing point and shoot, troubleshooting all over the building. And it's not as if you cannot do that, but just the cost of sending an electrician every time moving the sensors around the building becomes costly.
Do you recommend it long term?
Can we get a sense of which industries are represented here in the audience? Industrial machinery, government's here. Education. What level of education? Okay.
But we're implementing an Internet of Things program, so it's just very interesting.
There's obviously a lot of data that you're collecting here. I see a lot of work being sent out by email and things like that. Do you have any kind of putting my folks into a other third party like EFMs, like to actually send that to a different work tracking? Because
No, so it's one of their partners. Point 6 wireless is what we're using for the temperature probes. Mm-hmm.
Put it on and it's on the dashboard.
Mm-hmm. That's right.
Are there any other probes like sound sensors or accelerometers, pulse sensors?
Not presently, but we're open to adding more sensors.
I mean, I did research with chatter detection on machine tools where we just listened to the machining environment and based on the frequencies, we changed the feed and speeds at the VM. And we also did it with power consumption too.
Mm-hmm.
So, you know, but it was in the old days before wireless and everything, so it was hard.
These two, if you have such moments of feedback, and first of all, this is a little bit of the technology we use. So go in and test it out. You don't need sensors, you need the sample data. When you get some feedback, you will here, there's email address there, we can leave our cards here, and we can start communication that way.
Have you guys ever thought about taking your product into more broad appeal, like actual building sensors? So not just machinery, but I mean, just listening to some of the ideas he had, if you could use that, those kind of probes, you know, in the early part of constructing a facility that wants to pay close attention to how the building's actually performing during different times, whether it's maybe refrigerant areas or all. I mean, I can think of a billion ways that this could be.
You lead the ones to track all the time.
Yeah, I'm just wondering if that's the process you guys are considering. You know, I'll buy 100 of those things and just throw them in my walls and find out the temperature throughout the cold seasons and stuff. I'm just curious.
That's the idea. That's typically load-intensive buildings do work better because then you get the power right.
Okay.
But your commercial buildings, they have fires running in, education, university, government, business association, actually other leaders, those kind of things, high-tech companies and power. So,
Okay.
All right, well, we'll hang around here for a few more minutes if you have any more questions. Thank you, everybody, for your time.